Hello guys, welcome to Backbencher Studies channel. In the last video, we have discussed how to represent the systems based on the block diagram techniques, and we have already solved how to simplify that a complex block diagram into a simple transfer function based on block diagram reduction rules and based on equations we have solved. So in this tutorial, we are going to learn about signal flow graph. It is a graphical representation of this block diagram. We can also represent the block diagram as a signal flow graph. In the coming lectures, will be learning how to do that. So first, let us see what is a signal flow graph is. So the electrical signal which is being fed into the system flows into this continuous uh, array of systems or continuously throughout the system and thereby giving us the output. In a similar fashion, the here in this, so the signal flow graph gives how the signal flows throughout the systems, and thereby we can calculate the overall transfer function using signal flow graph using one formula called Mason-Gaines formula. So let us construct the signal flow graph for the following sets of equations we have. So x2 equal to a12 x1. So here these are the simultaneous linear equations which we have. These set of equations should be converted into a signal flow graph. So here x2, x1 and x5 and so on are the signals which are at some point, maybe they are voltages or maybe they are current in a particular branch. So how we do that? So first we will be observing how many number of variables are there in our set of equations. So we have four, and observing we have four variables which are x1, x2, x3, x4 and x5 in all the four equations. So we made the nodes which are representing the variables at each point. So what we do next? What we do next is by analyzing these equations, we can construct the signal flow graph. We'll be doing that. So we have the first equation which is x2 equal to a1 to x1. So the x2 is signal is formed based on a12 times multiplied with the signal x1 and a32 times. So the x3 signal is coming multiplied with a32 and x4 signal is coming with a42 and x5 is signal is coming to x2. So all of these are incoming signals which are being added to form the x2 signal. So how we do that we can see. So we have this A52 kind of signal which is coming to x2 to form. So in this previous session we have previous slide we have seen. So here likewise, so if we, so and here we have a12 which is being coming from x1, so we added that, and we have a32 which is coming from this x3, we have added that based on equation 1, and we have a4 which is coming and we have added that. So all of these resulting into x2. Similarly, if we do on in the next step based on next equation, the next equation is for next equation. Based on next equation we will be doing that. So if we do for all the four equations, the following signal flow graph will be appearing like this. So the x4 which is being formed by this x3 a34 x3 x4 x3, and which is also forming from x1 also. So x4, based on x4 equation we have solved this node, and x5 based on so based on the fourth equation we have solved this x5 which is being a45 into x4 which is being derived from this. So is this signal flow graph complete? No, it is not completed. So we it is somewhat incomplete because how the signals are being added, it is coming into the signal or it is leaving out of the signal. That is very important because that determines the sign of the signal, particular signal variable in that equation. So what we do is we add arrows representing whether it is incoming to the node. If it is incoming to the node, we add that with a plus sign, and if it is outgoing, we add that with minus sign. So here in this way, if we add all of these directions, we have this signal flow graph which is being represented by four equations. So coming to the elements of the signal flow graph, we have nodes which are being represented as variables, and which are like this. These are nodes x1, x2, x4, and 5. Branches, which are line joining these nodes, are called branches. We already saw. So input node, we have only one output going branch, which is the input which is being fed into this node. So we have only one outgoing branch. So that is what we call as input node, and output node only incoming branches are there. So here, if you see x1, only outgoing branches are there. So this is the one outgoing branch, and this is another outgoing branch. So only outgoing branches are there. So we can consider x1 as input node. And if we see x5, it is having only incoming branches, which is one which is coming from x4, one which is coming from x3, and one which is coming from x2. So we can say that this is an output node. And path, coming to path, so way connecting between these two as per the directions, this is important. So in the direction of arrows we should know. So from input to output, if you are going, so we what are the paths? So let us see. We can go straight in this way because arrows are supporting in such a way. So we cannot go like this. First, we if we go to x2, and then we cannot go in this path because the arrow is opposing. And based on this arrow we can go. We have three paths over here. If you have seen forward paths are paths from input to output nodes. And loop, you already know, which uh, which is kind of a circle kind of thing, and which starts at the particular node and which ends at the same node, that is called loop. And self loop, and if only one node is intervened into this loop, that is called a self loop. These are the elements of signal flow graph. And thank you guys, thank you, that's it for today. And we have covered so much, so please do watch this video once again to kind of get clear the things. So thank you guys, thank you for watching. If you liked the video, please do subscribe to our channel.